Hello, ladies and gentlemen of my physical science class. Mr. Hescox back to you. We are moving along in Chapter 7. Your home warm-up question there was to give an example of a synthesis reaction. So synthesis would have to be combining two things to make a larger or more complex substance, such as taking hydrogen gas and oxygen gas, burning them, and getting water. We're going to talk about energy changes. There's two types of energy changes, gaining or losing energy in a chemical reaction. Your homework is 214 to 219. You got to read it, and then the review questions will go along with that. In the one video, and sometimes in class, we do the Alka-Seltzer and water. You have the carbonic acid with the sodium bicarbonate, gives you carbon dioxide plus water plus sodium carbonate. Chemical reactions involve energy changes. I know my kids love to play with these light up sticks. You crack them and then they start to glow. Well, this is giving off a type of light energy in this case. If it was giving off heat, that could be an energy change. So these are all involved with bond energies. Chemical reactions always need a little bit of energy to start. Then they either continue to gain energy or they continue to lose energy from that point. That energy needed to break the original bonds and start the energy is what we call our bond energy. If more energy is released than is required to break the bonds, the reaction is exothermic. Exo means exit or to leave. So this is energy leaving. If more energy is absorbed, meaning going inside, then we say it's endothermic. Endo means into or being absorbed in this case. Energy is always absorbed at first, but then it will continue to be absorbed or continue to be released. So let's talk a little bit about types of reactions. So an exothermic reaction releases energy. It can be sound energy, light energy, or heat. The more energy is released, usually it becomes a heat thing. As the reaction progresses, once you absorb that little bit of energy to get it started, it goes and it reduces, and you'll have a product with much less energy than what the original reactants had. So here's the energy of the reactants. This is our bond energy or activation energy, we call it. And then it releases energy. So you see this energy going down. As that energy is released, you end up with a lower energy in the products. This here is called the activation energy. The exact opposite of an endothermic reaction, or is an endothermic reaction. So endo means inside or to absorb. So that energy is going into our reactants and actually going to give you products that have more energy in them. This is a real good example of a lot of decomposition reactions are going to absorb energy, and photosynthesis absorbs energy. Here we have this low energy, and then you have higher in the products? Well, the products of photosynthesis, sugars, what we use for energy. So when we talk last, kind of wrap this up here, exothermic reactions generally release heat or light. Think of fire. It's really hot, gives off light. Endothermic reactions are going to feel cold. If you've ever seen those emergency bags that you crack and get really, really cold for first aid kits, that would be the perfect example for that. If you can reverse an endothermic reaction, you can actually cause it to become exothermic. At the same time, if you take an exothermic reaction and reverse the arrow, it can become endothermic. All right, ladies and gentlemen, that takes us to the end of Chapter 7, Section 3. Make sure you get that reading done, and if you are confused, feel free to go back and watch this video or watch the little videos in the Google Slides. Until next time, I'm Mr. Hescox. See you later.